thanks very much for coming along, everybody. This is a bit of an experiment for us in engineering and the sciences, so really thrilled to see so many people come along. And I'm particularly thrilled that Geoff here has agreed to be our guinea pig, so thanks very much, Geoff. My name's Geoff Spinks, for anyone who I haven't met before, and one of the things I do at the moment is a leader for the Manufacturing Innovation Global Challenge program, and one of the initiatives that program has started with is a series of a conversation with. So we're number 2 in that series. There was a very successful one a month or so ago, and we're number 2. So the idea really is to blend a bit of social and also information together and in a sort of relaxed format. And it's very much audience participation. So the idea is to, if you have any thoughts or comments or questions, please leap out of your chair or at least put your arm up. And Kate, who's at the back there, has a roving microphone who will attempt to get it to you, and we'll take it from there. The reason we're using microphones, by the way, in such a small room, it seems a bit strange, doesn't it? But this has all been recorded by Mark here, and there'll be an edited version of this conversation.
Heavily edited, I hope.
We won't edit out your gags, though, Geoff, so that's the purpose for it. But anyway, let me introduce Geoff. Geoff is an old friend of ours. For the outset, I thought I would try and explain that we're not exactly clones, but we are close. We have similar names. We both worked together in the Department of Materials Engineering back in the 90s here at the University of Wollongong as lecturers and senior lecturers. We both came from Melbourne, and we have both had fairly similar interests, but that's where the similarity is. We are actually different. We're not twins or clones, right? So no, Geoff was at UOW from 93 to 2000 in materials engineering, and then he went to Canada to McMaster University for a few years. And then we lured him back to Australia, fortunately, to CSIRO from 2004 to 2006 as a senior principal research scientist. And then in 2006, Geoff joined Swinburne University of Technology in Melbourne, where he has risen to the rank of Pro-Vice Chancellor, Future Manufacturing. So in a sense, as I understand it anyway, that's a similar role to what I am doing in terms of a whole university approach to sponsoring and promoting manufacturing type research. So it's terrific that we still have these similarities and similar interests. So that's really great. So thank you again, Geoff. We'll see how it goes, and we'll just have a bit of a chat. Forget there's an audience there.
I invite heckling, and heckling is allowed.
Yeah, I think we've got a few hecklers at the back. But no, thanks again for doing it. So just to get started, I thought I'd just ask you a little bit about your own research and what has really driven you. You've had more than 2 decades of looking at materials, particularly the way that we make metals. So what's your passion? What are the things that really get you going?
Well, initially I got involved with metals research because I was interested from the environmental perspective. So that was my initial impulse. Like, all right, can we make metals but without lowering, with at the same time lowering the environmental impact of making them? So this is in the late 80s, and at that time there wasn't a lot of research topics with that kind of slant. But fortunately, I found a supervisor who was interested in that. I think as I've gone through, I'm still interested in that. In fact, quite a lot of my research is in that area. I do a lot of work on, for example, e-waste recycling at the moment. But I suppose I've become a little bit specialised in a few areas, particularly in steel making. And I think that I'm very excited about steel making research because though it's a mature technology, it's remarkable what we don't understand, and there's also a lot to improve. So I'll put it in really simple terms. Basically, the vessels that we use to make steel across the road from here, I think that if we were cleverer and smarter, we could make twice as much steel with the same vessels, or vice versa, have a much smaller plant and make the same amount of steel. And I think that's quite possible. And so that's exciting and interesting, and that kind of thing certainly motivates me. I think another thing that interests me is trying to come up with novel routes to make materials. And you mentioned I was at CSIRO, and I led a team there where we developed a new way of making magnesium, which is at the moment trying to be commercialised. So that's pretty exciting because you always want to try and come up with a better way of making things. So yeah, I think I started off in the environmental side, and I'm still motivated by those things, but I find myself wanting to innovate and improve the processes. And, something when you look at it, if you can just improve steel a little bit, that makes a very big difference to the world, because the steel industry is such a major industry. So there's some of my motivations, Jim.
Yeah, that's good. I mean, I guess the point is that the massive volumes of steel that are produced worldwide, that if you can make even small incremental improvements in the productivity or the environmental impact, then you're really onto something, right?
Yeah, I think one of the things I think that's a little bit misunderstood, I don't think this audience would have this problem, but it's a common misconception people have that, steel has reached its cusp and it's dying out. The opposite, the complete opposite is true. In 1999, there was 790 million tonnes of steel made, and now there's over 1,500 million tonnes. So we've just seen the greatest industrial revolution in the history of humanity. That's exciting and interesting all at once. So yeah, no, it's a very dynamic and interesting industry, and I don't think it's about to change that interest to me.
Well, I have to be a little bit controversial. No, I couldn't have it here, Jeff, without being a little bit controversial. But iron's been around since the Iron Age, and you need iron to make steel. But so what is there still to do in terms of understanding how iron and steel are made?
All right. I think some of the challenges are to do with sustainability, and I think, for example, if we're going to really have a sustainable society, then we have to have really good recycling technology. And I would describe steel recycling technology at the moment as not bad, okay, it's got some good features, but it can be improved a lot more. I mean, the dream of all recycling technologies is you go from junk to high quality product. I mean, that's the ultimate, what you're trying to achieve. And steel is on that path, but it still has some way to go. And a lot of that comes down to some very precise chemistry and about clever controls and some very, precise topics which would bore this audience. But I would just like to say, there's a lot to be improved in steel recycling. That's one thing I think that certainly can be improved. I think the other thing also is look at the scale of steel plants. They're still enormous, great beasts, huge rolling mills. And I suppose a really obvious comment would be that steel is at the moment not a fully continuous process. Parts of steel is continuous. The blast furnaces run continuously. The caster's continuous. There's a lot of intermediate steps. And if you look at any really mature, efficient process, they tend to be basically continuous. So I think there's some revolution still to happen. You knew I was going to say that.
I did, and thanks for educating me once again. One apology today is our former boss, Drew Stunn. He's unfortunately couldn't make it along, but he sends a question. In typical Drew style, he sends a kind of tricky question. He's interested to know, what do you see...
I need to tell a story here. This is important. When I was offered the position at Wollongong, I was a PhD student at the University of Melbourne, and I was very nervous and very respectful of professors. I now realise professors are nobodies. I fully appreciate that, but at the time I didn't.
I take that personally.
And the head of department at the time was Professor McKinnon. I was very nervous about him, and he rang me up just after I got offered the job, and I thought he was about to say, "We've come to our senses and we're not giving you the job." He said, "Look, Jeff, we need some clarification about something." I said, "Yes, what's that? Could you explain to us how the AFL final series works?" So is it a question like that, Jeff?
You must have got that right. Yeah, that's true. Now, Drew, he's interested in what do you see the future of blast furnace production of iron?
Well, we have a world expert sitting here. The blast furnace is obviously going to be the dominant iron-making technology for the next 20, 30 years. And that's very interesting to reflect why that is the case. So in the 90s, there was a great deal of research where people thought they were going to replace the blast furnace with new iron-making technology, in particular direct iron making. And I must agree, this is a great example of how not to follow the crowd. Because in 1994, if you'd asked me, I would have gone, oh yes, I'm sure direct iron making is coming around the corner. And some of the logic in retrospect was so stupid. For example, one of the logic was, we're going to have a shortage of coking coals. Remember that argument that anybody's into steel making? Well, that turned out to be really ridiculous, right? And so what I think what's happened is that during the 90s, all the effort into direct iron making came up against the fact that the blast furnace is really a very impressive reactor and really a pretty good technology, not perfect, but a very impressive technology. And I think that now that China has invested this enormous sums of money into a blast furnace technology over the last 10, 15 years, then I think it's going to dominate for another 30 years, because basically you don't put that amount of money into that sort of equipment and just turn it off. It's just not the way the world works. So I think that basically the blast furnace will dominate for the next 20, 30 years. However, I do think other iron-making technologies will be tried in countries in particular situations, and some of them will succeed. And maybe that will change the balance between different iron-making technologies. But I think Bob's in a job for quite some time. I think he'll be able to go and consult people about blast furnaces for a long time because of that massive investment made in China. That's a very interesting point, though, is that sometimes technologies are about timing. So when you look at technology, sometimes a really good idea doesn't get off the ground because of timing. It's not actually because it's not a good idea. It just happens to be it's at the wrong time. And I think direct iron making was sort of at the wrong time and it didn't take off. And if it just sort of matured quicker, then maybe China would have built a whole lot of different sort of iron making capacity. But they've built all these blast furnaces, and I'm sure they're going to spend the next 20 or 30 years trying to optimise them and make them run better.
Okay, thanks very much. I'll try and remember anything sensible from that and pass it on to Drews. Yeah, but I want to move more about the steel industry rather than the technical side of things. And you've written that for Australia, the steel industry is a vitally important industry. Just wonder, why do you see it that way? We could import all the steel we needed, but why do we need a steel industry in your view?
All right, well, of course, I love steel, so I'm biased. I have to acknowledge that. But let's just try and look at it rationally. Look at the countries that you admire. Think about countries that we respect. And if you look at the countries that most of us respect in terms of having, excellent living standards, good environmental conditions, high education, etc., they're normally linked to having a pretty good steel industry. And it's not surprising because steel remains a particularly good way of measuring wealth and prosperity. And you can see that Northern European countries, they make good quality steel. They don't try to compete with the Chinese and perhaps the low end of the market, but they try to make high quality steels that go into high quality products. And we noticed that our friends in Japan and Korea, they started off making a lot of steel, and as time's gone by, they've got more and more into the high value. And all of us, I look across the room, there's a few children here, but most of us are old enough to remember when, a Hyundai car or a Korean cars were perhaps not the most desirable car in the world, But now they've become quite nice cars, and people are willing to pay good sums of money to buy those cars. And we can remember the Japanese auto industry going through similar things. So when you look around the world, you see that basically there's a very strong link between having a strong, robust steel industry and wealth. And I don't think that we should undertake this experiment of not having that connection. Actually, there's one country that kind of rocks that trend, and it's worth analysing that country, and that is England. So England, UK in general, got rid of a lot of its steel industry in the 80s, as many of you'd be aware. And they didn't get rid of it entirely, but it got rid of a lot of it. But it's been able to reinvent itself in finance and services. But it's, of course, next to the EU, and it's kind of got this historical connection. But I think even now, if you spoke to a lot of people in the UK, they would regret that. They would say we should have still kept our strong metals industry and built up our services, because it's made them vulnerable to particular changes. So I think basically in summary, there's a strong connection between having a healthy steel industry and having a successful country. And I think Australia should be conscious of that when it's making choices about how it's going to develop that industry.
So it's sort of like a barometer of our standing in terms of technology and also being able to compete in a world market, I guess.
Yes, and I think just on that, I was very thrilled this morning to walk around the innovation campus and see some of the really interesting work about trying to come up with novel roofing products that combine solar energy with steel, trying to innovate and bring things, new technologies together. That kind of thing is very heartening. I think Australia just needs an awful lot more of that.
Yeah.
Basically, I mean, I think that's very great, but we need more of those things and more investment in innovating in this important area.
And there still seems to be plenty of opportunity to do so. Now, Wollongong is a steel town, steel community. It's the steel works has been the mainstay of employment in this area for a long time, and the steel industry is still here. So how do you see the relationship between a big industry like BlueScope Steel in a community like Wollongong? You've written that it's important for steelmakers to be engaged and interact with their community. So why do you see that as important that a company that's located in a region, that a big employer has that community engagement?
Well, I think once again, it's always good to look for role models in terms of how are things done well. And some of you in this room may be aware of the Nucor company, and the Nucor company is a very, very successful steel company, and its model has always been that you create a steel plant in a community that is invested in that plant, in the success of that plant, and that by becoming very involved with everything the community, including the whole environmental side, so everybody kind of knows what's going on and understands, if we want to lower that emission, we need to make this change, and etc. And so it's not an us and them, it's more like, what can we do approach. And Nucor's taken that approach very successfully in quite a few places around the world, and I think a lot of steel executives are well aware of that role model. And if I can contrast that with perhaps an old style of company where you might have a very hierarchical, company that's maybe got a headquarters a long way away from where the people live, those companies, quite a number of them have really struggled and struggled to change when things haven't been so good for that economy. So I think there's a lot of evidence to show that not just steel companies, but a lot of different sorts of industries do much better when they're integrated now with the community. But in the case of BlueScope, you need to give them a lot of credit. I'd be corrected that wasn't this originally some BHP property many, many years ago, this university site? I'm pretty sure it was.
Yeah, I believe so.
Yeah, and they obviously have invested quite heavily in the University of Wollongong in various ways. And that actually has helped that company a lot, but as well as helped the local community. And I'm not old enough to remember, but for example, I know that the environmental conditions in the Illawarra have improved a lot over many decades, and that's not by accident. That's because people have worked to improve things. So I think that there is obvious rewards. It's not the only reason why a company will succeed, but it certainly will help a company succeed within a community. And I think actually BlueScope has done pretty well in that area, actually.
Now, I've been forgetting myself. I've been a little bit rude. Are there any questions or comments from the audience? Please, if there are. Yeah, we have one at the back, actually.
I'm actually interested in your own career path. So you described, from what I understood, it sounds like you were a researcher for a while and then suddenly you became a research manager. And I'm interested in that transition from being obviously a successful researcher into a manager of what should be successful other researchers. Was there any training or preparation, or how do you make that transition?
Excellent question. I'll have a go at it. The first thing is that's a little bit, I think, has always stood me in good stead, is that I worked as an engineer before I did my PhD. So I finished my undergraduate and then I went and worked in industry, and really at the hard face of industry. I used to run a small factory that used to make things. So that's always helped me a lot appreciate the hard business side of things, which is good for an applied researcher. After I did my PhD, I had the best sort of training you could ever have. I had a great mentor. So my great mentor was a gentleman that many people in this room would know, a guy called Howard Warner. And Howard Warner was a very inspirational and amazing person. And he had a great record of success and leadership in this country, in research. And he showed me the ropes, and he taught me valuable things. And it's been very hard for me to crystallise all those things now. But, for example, he told me, you need to persist with your ideas. You shouldn't be put off if people don't initially welcome your ideas. Persistence in research is very important. And he also taught me that you should also listen to people. So the other side of that coin is that people make valid criticisms, you should take it on board and try to make sense of it. And wherever that comes from, one thing about Howard that I always found very inspirational was by the time I was working with him, he was quite famous. He'd won every award conceivable that you can win for research. And but if an undergrad student came up and wanted to critique what he was doing, he would listen and try to make sense of what they were saying and see some... so he taught me this business of making sure that you believe in your own ideas, but at the same time you are not closed off to other people's thoughts. Now on the leadership front is Howard used to always have a basic policy of that if he met somebody he thought had ideas in whatever field it was, and he thought they were clever, he would do all in his power to encourage them, motivate them, support them, if he thought somebody didn't have very good ideas or perhaps was not a particularly impressive person, he wouldn't try to do anything negative about them, he just wouldn't step out of his way to help. So he'd back you. If he believed in you, he'd back you. So I think that's a very important thing in leadership that I've learnt, that when you see talented people, you need to support them and you need to encourage them and you need to be positive to them. And I certainly get that from Howard. And don't waste your time trying to knock somebody else out. Or when I've spent when I think of time I've spent involved with some petty politics within all, I regret that because most of it is just time wasted. I try to think of what Howard would do, which would be forget about that and concentrate on doing something positive yourself or encouraging another person to do something positive. So, yeah, I think mentoring, if you can find somebody that can mentor you, then that's good. Can I tell you something I'm a little bit jealous of many people, is I went straight from PhD to teaching as a lecturer. I never was a postdoc. And in fact, it's one of my great ambitions of life is to be a postdoc. So I'm hoping that when I get to a certain stage in my career, I can convince somebody to let me be a postdoc.
Well, the solution, as you know, Howard Warner was coming to Wollongong where he thought he'd have a nice retirement, but he was coached out of retirement by the Vice Chancellor of the day, and he then went on to set up the Microwave Processing Centre and to lead a really amazing research program, including Geoff. So maybe that's the way to do it. You just retire and then you come back and have a great time.
Well, I'm also thinking of, as you've been talking, I've been thinking of something else that I should point out to you. Another role model came from history. If you read about Ernest Rutherford's research group in physics in McGill and Cambridge, and how he managed that group and how he promoted that group and how he got that group to work on amazing topics about the structure of the atom and etc. I read that when I was a boy, and that inspired me and actually still inspires me. So sometimes you need those role models, whether there's something you know or something in history that, because the issue of research leadership is not new. So I suppose I would give you advice. Find somebody you admire. If they're alive, try and get their advice. And if they're not with us anymore, then read what they did and try and see what you can learn from it.
Thanks, Jeff. Another question, Peter.
Yeah, carbon is a dirty word, or depending on your political persuasion or country, with maybe not. What's your take in regards to carbon usage within steel manufacturing and in the manufacturing industry in general? Is it overrated or is it a serious problem? And should we nationally be looking into that issue with carbon?
Yeah, I first of all would like to distinguish about the two different uses of carbon. Carbon that's used for burning to generate heat and generate electricity, I think is not a particularly wonderful way to use a relatively limited resource. So I'm not saying therefore let's just scrap all carbon-fired electricity stations, that's very naive, we can just do that. But certainly you have to acknowledge that burning coal to make electricity, when you look at all the inefficiencies, they're very large. Now, when you're trying to use carbon for directly making something, as in the case of making metals through reaction with carbon, then you're saving yourself a lot of energy, because if you look at the thermodynamics of that, that's actually a very efficient way of using resources. So when you're making metal using carbon, that's a valuable way of using carbon. And there are other ways of using carbon in chemical reactions as well that are also valuable. I happen to know about metals. I think that usage of carbon is quite justified, and it's probably the way that we're going to be making metals for a long time. I think we should try to limit the amount of carbon that we use to burn and make electricity. And I think some of the answers are, combinations of renewable energy sources, whatever. But I'm not naive. I realise that those things will take a long time to develop. They're not straightforward, and you've got to find somebody to invest in them. I do some of my own solar research, and I don't do solar research through the sense of believing that everybody should invest in that tomorrow, but I do think that people like myself should try to put some of their work and effort into moving our energy away from relying on burning of coal for electricity. But I think there will always be a good use of carbon in trying to make metals and other chemical uses. So that's how I see that carbon debate. I personally didn't think it was totally objectionable having a carbon tax or some sort of price on carbon. I do think it was a bit harsh on people who recycled materials using energy in that way, not to get some benefit of that accredited to them. So for metal recyclers, to be penalised the carbon tax like everybody else, I didn't think was a very good thing. But the general idea of putting some price on carbon, I personally thought was a reasonable approach to trying to limit the type of carbon usage I talked about.
Yeah, I tend to agree. Any other questions just at the moment? Or I'll go back to my script. Actually, you mentioned Nucor, and you spoke about how they were involved with setting up new ways of really, fixing the ailing US steel industry. And you've spoken about Ken Iverson, the boss of Nucor. Are there any lessons we can learn about what happened in the US, particularly in the sense of introducing of new technology and new management practices, and, as you mentioned before, engaging with communities and so on?
I think so. I think when you start off in a technical area like me, you tend to put all the emphasis on technical breakthroughs, and you think that everything's about, coming up with the next smart alloy, or the smart way of making steel, or the smart way of doing anything. But when you look at it a little bit more objectively, you put yourself away from it, you can see that the way that companies are run make a very big difference. I was in North America for a while, and it was immediately obvious the difference between well-run companies and not so well-run companies. Yeah, and in Australia, one of the things that we have a little bit of a problem is that often we can see at the moment in food, we have two major supermarket chains. So quite apart from the uncompetitive nature of that, it's also uncompetitive with themselves. In other words, best practices and making sure that they're clever. And that's true in Australia as well. And we've got two steel companies, and if you go through many industries, we have just one or two companies. Where the thing in North America is there's so many companies, they tend to be very, very competitive. And if somebody starts operating in a smarter way and finds a better way to motivate employees and a better way to organise labour and get on with people, then the other companies have to pay attention, because you can go astray very quickly. So I think that there is a lot to be learnt from, you mentioned Nucor, but there are other companies. I was very, very impressed when I went to Korea by visiting POSCO. Wow. They have a tremendous commitment to R&D and a tremendous commitment to excellence in their research and work. And the whole company has this strong belief that you have to be clever to succeed. So they don't believe they're going to succeed by just doing what they're doing. And I think, so there's a number of companies, not just the ones you mentioned, but I think it is important for not just business people, but technology and science researchers to be aware of these things and learn from these companies and not be naive. Because often a lot of the reasons why companies don't succeed is not because they don't have the right technology. It's most definitely they have the wrong structures or the wrong approach to business.
So it's innovation really across the board. It's not just the technical innovations. It's management innovations. It could be marketing. It could be the way that the human relations are managed and so on. There can be lots and lots of ways to be innovative and to improve practice.
My brother-in-law happens to work for SpaceX. Now, SpaceX, what a fascinating company. SpaceX is started off by the gentleman who made his money from PayPal, Elon Musk. And his idea, he recruited my brother-in-law, worked for NASA. He's a rocket scientist. So as you can imagine, I'm the dullard of the family when you have a famous rocket scientist among your family. And Elon Musk approached him and basically said, well, NASA is a public service, so therefore fundamentally there's no way in the world that I couldn't be cleverer than them, which is a pretty reasonable premise. And he said, I can definitely make rockets cheaper than them, I can definitely make space travel much cheaper than them. That was his opening premise. And yeah, he's right. He's absolutely right. And you can also see this issue about, you mentioned marketing. I'm not a computer scientist, but I don't think the reason why Apple Computers has succeeded because it's got the most incredibly technologically advanced computer of all time. Though I'm not saying they don't have nice computers. I don't want to say that whenever you meet someone who's a real Apple fan, it's not a territory to go in. But anyway, let's just say they have nice computers. No, it's brilliantly marketed. It's the whole image of owning an Apple and the whole ideas that people have around using Apples and its integration with all its other services is obviously a huge part of its success. So, yeah, and we're engineers and scientists, a lot of people in this room, so we're not going to be the experts in that. But certainly it's good to be aware of those things. And I think in my new role, and similar role to you, is trying to help companies. When you go to talk to companies, to be honest with you, it's not very often they say to you, could you please get a PhD student onto this topic for us? That's not a very frequent conversation. Normally the conversation is sort of like something that's a combination of technical and something to do with some management issues maybe, or perhaps the way they present their products. And I think that universities, if they're going to help industry, need to be, obviously aware of that and trying to help them, because it's a reasonable idea that universities try and help industry succeed in our country.
Well, one of the impressive things about Swinburne is the design school and the design factory. So do you hang out with those guys much? They come from quite a different background.
Yes, I hang around a lot with designers now. It's not showing me the way I dress yet. I'm sorry about that. I have a lot of friends in the design school. They're very nice people. I think we can learn a lot from the industrial design school. We've done something very bold. It doesn't sound bold, but it is bold. We're putting the designers and the engineers in the same building. So that's a fascinating concept. And I think it's a good idea. When I look at a lot of issues in Australian manufacturing, they are about that very issue. How do we get our clever design ideas into manufactured products? Because something, you look for complicated reasons about why some of our industries have failed, and really they're not that complicated. Why have our car companies struggled? Because we're not making cars that many people really want to buy. Why do we pay a lot of money for BMWs? Because they're highly desirable cars that many people around the world would like to own.
Except academics, of course.
We can't afford them. And you can go through that whole range of products. So it's very, very important to get our design people working closer with the people who are clever in manufacturing and clever in making things. And I think the time for that is very exciting, because we're seeing this breakdown between ideas and making things. The revolution of digitizing, being able to go from an idea to a digital version of that idea, and then making something and testing it and checking out its properties, and then is now so much easier than it was even just a decade ago. 20 years ago, CAD drafting was sort of slightly on the edge. Now it's completely standard. Modelling things in virtual environments probably 10, 15 years ago was sort of the cutting edge, and now it's pretty standard techniques. It's as simple as this. People can come up with ideas and maybe mould something out of plasticine, and somebody can scan it, turn it into a digitized image, start manipulating it and printing something out in a metal, or fabricating something in a hurry and having a prototype within hours. So less than hours, in fact. So you can actually idea to product. That is shortening dramatically, and I think it's an exciting world to be in, and that's where a lot of need for innovation and fleet-footed thinkers is required.
So you mentioned putting the engineers and designers all together, and that's in your nice shiny building, right? That's on Burwood Highway, the shop front, and this is I think tentatively called the Factory of the Future.
Yes.
So can you tell us a little bit about that and what you're planning to put in there?
Yeah, well, first of all, we should remind we have another factory at Swinburne called the Design Factory, and the Design Factory is it's a great idea. What it is it's set up by Stanford University and with Aalto University and Tongji University and Swinburne. And what they do is they go to companies and they say, give us your problem. You want to develop a product. You need a new product, or you want to improve a product. We'll get 3 or 4 design students from each of those institutions to go through the problem of different aspects. Some could emphasise the mechanical design. Some could emphasise the marketing. Some could emphasise the manufacturing of it. And they then work together, and they have big, large television screens connecting all the laboratories together, and they sit there and go through ideas and put sticks into the bottom of the computer and send each other's designs and etc. And then come up with a finished product for the company, and with prototypes and costings. So that's the way our design factory has been working now for a few years, and it's very successful. And companies like working with them, and the students would like it. And to be blunt with you, I feel like enrolling to be an industrial design student is a lot of fun. What we're trying to do now is find manufacturing research into some sort of coherent structure that you can use for similar type approach. So we're calling it the Factory of the Future. We tried 300 other different names and we settled on that. And what we're going to do there is try and make a place where you rapidly develop products. So the idea is we're getting all the expertise in the university that we have about design and manufacturing, and trying to make it a sort of one-stop shop. And what we're going to have is we're going to have the latest visualization and design software and equipment, and immersion cells and tactile design equipment. You can now, some of you may know this already, but in case you don't, you can now buy software where you have a device in your hand and you mould in a 3D image the shape that you're looking for on the screen. And these kind of tools, which we're still trying to fully, optimise. And then we're going to use that to rapidly make things, and using both 3D printing but also other rapid manufacturing equipment to actually make the object. And then once we get the object, we're going to test its qualities on the spot. So we're going to have all sorts of scanning equipment to check out the quality of what we've made. And then to add on to it, we're going to check the recyclability of it. So we're going to break up the prototype and see how many of the components we can recover meaningfully, so we can actually check the recyclability on the spot. So basically it's a one-stop shop for developing new products. And it's what Swinburne's attempt to address what we think is a need in the industry, and also we think it's important for training our students.
That sounds very exciting. I'd like to enrol as well. I should check, are there any questions or comments from the audience? Oh, there is one, Katrina.
I've been working in Illawarra, probably with industry for a few years as well, with Regional Development Australia, and we had a project where we actually invited a lot of the manufacturing SMEs and engineering companies to different workshops to actually expose them to knowledge. So bringing clean tech companies down from Sydney who had head offices there to show them what wind projects they're working on, etc., things like that. But I think for them going away then to take that knowledge, they take the knowledge and probably not do anything with it. It's just a matter of how they convert some of that information, what other skills they need, or I'm just thinking about those sides of things. You're talking about people and process, but also what do we need to expose them to, if at all, whether it's knowledge or whether it's other attributes as well.
That's a very interesting issues you brought up there. You're talking about the issue, I think, of you can expose people, SMEs and companies, to new ideas, but then translating that into a change into their company. Now, I think that's where organisations that are set up by the companies can help. Now, in Melbourne, we have what's called SEMA, which is the South East Melbourne Manufacturing Association, I guess. And it's basically just a group of companies who help each other. So there's about 20 or 30 companies, sometimes competing, not always, but sometimes. And their basic goal is manufacturing needs all the help it can get, so we're going to help each other. And they actually have experts from their companies going in and walking around their factories and going, do you know something? We put in that type of thing there, and we found that worked a lot quicker, etc., etc. So that kind of hands-on improving your company can often be done with companies helping each other. Now, in that case, they get a little bit of money from the government to have an office and employ a few people. And I think it's money very well spent, and there's some very concrete examples of that. If you go to the STEMA website, you can see that they really have helped each other. So I think that's one way of translating, of helping things. The other way is I think that the government, all our governments, need to come up with much more responsive funding to help companies innovate. So this is my chance to be controversial. Current official system of the Australian government to help companies innovate, and say somebody from a sheet metal company down the road gets very excited about 3D printing. They come to a nice exhibition here at Wollongong, and they're all excited about it. They go back, I want to do that. Well, our official system at the moment, if they want to try and do that, is they need to convince an academic to fill in a 90-page document, which then is sent off and takes 9 months of assessment. I repeat that, 9 months. Now, anybody here who's worked in the industry knows what 9 months means to a business. It's just like a lifetime. And then, amazingly, we get people who are potential competitors to the researcher who's asking for it to assess it, which is an extraordinary notion in itself. And then, once we've gone through that extraordinary system, one out of four people get the funding. That is not a formula for innovation. That is actually almost a formula for the opposite, actually. And to make it even worse is it used to be some years ago that if you had a half good idea and a credible research record, you could reasonably expect to get that money. Now it's becoming, please, if you don't have over 100 papers and some citation index, you probably haven't got a chance. So, what can we do that's cleverer than that? Well, a lot of things, and some governments are doing things like voucher systems. And what they're doing there is they say, all right, you want to do research with a university, why don't you do a project that takes 4 months? If the company will put in $15,000 to $20,000, we'll put in $20,000, and the paperwork is more like 2 or 3 pages, not 80 pages. So I think there's ways that governments can help that. And at the moment, a lot of companies realise that they need to innovate, but they lack the kind of money to just sort of push across that barrier. And I think we need more of not just governments, but also universities helping that way. So universities can help. For example, we can do things like say, all right, well, why don't we get a couple of good final year students onto that project, would you? Let's see if we can try and improve the way that you're operating that part of the plant, or why don't we try a prototype in our labs at the university? We can do things to help that way, and a lot of universities already do, but I think there is a real need for reactive funding that helps companies to innovate and be cleverer, and I think that's something that's a hole at the moment.
I totally agree. Sharon?
Okay, this is a question perhaps for both of you, if I'm allowed to do that.
How do you spell Jeff?
We've been talking a lot about manufacturing, and you've highlighted on a couple of the differences between what you see in Australia and what you see when you go overseas, particularly to Korea or the United States. Having been involved with industry and manufacturing and academia for over 30 years now, there's been this trend where companies in the global economy take each other over, buy out the Australian company, they move all their R&D overseas. That happens more and more all the time. The number of companies is getting smaller and smaller. At the same time, Australia suffers from this distance from other economies that you commented on, the UK location next to Europe being a big advantage for them. So given those sorts of factors in a changing global economy, is there actually a future for manufacturing in Australia, or are we going to be the ones who innovate stuff that gets made overseas?
Yeah, well, that's a common point raised. So I would turn that on its head. I'd just turn that problem on its head. So let's look at it. What regional advantages do we have? Well, I've noticed it's a very, very short flight to Indonesia. You've been on that flight, I know you have. It's easy. We can fly to Indonesia so quickly. Indonesia has 250 million people. It has a middle class that's growing at an extraordinary rate. It currently has quite low levels of production, all sorts of manufactured goods. I think something that would be very sensible, and I would imagine that smart companies, I'd hope that BlueScope's one of them, have already been thinking to themselves, what is the middle class of Indonesia going to be buying over the next 20, 30 years? I'm just using that as one example. There's a clear local, we already have established relations. They're right next to us, and there's a big population with growing wealth. So we need to look for those regional advantages. We need to turn that problem on its head and look for what advantages we have. And I think, we have other clear advantages as well that we shouldn't take for granted. We're a very peaceful, well-run, maybe over-regulated, you could argue, but we're a well-regulated, well-run country with a highly educated workforce, and we have lots of clever people. These are all good things. So what we need to do is turn that towards our own advantages and look at that. I think also the bit about the internet is interesting, isn't it? Like, I don't know about you, but I don't really care which country a product I really want comes from. Like, I used to be nervous about buying things on the internet, but if I see an attractive product, I don't mind ordering it. And that is a trend that is growing throughout the world. So that actually kind of helps you around that problem. But what it does mean is you can't be just selling something that's very standard. So if you make very standard things, that type of approach won't work. But if you can make some very specialised products, then maybe that doesn't matter so much whether you're in Australia or Sweden or wherever it is. Maybe it's just enough that you know some special skill. And Sharon's looking at me sceptically, so I'm going to give her two examples.
Okay.
At the moment, Australia is a world leader in carbon fibre reinforced plastic technology for making the part components of aeroplanes. And if you go down to the Boeing plant in Port Melbourne, you'll see a very impressive facility that is obviously generating a lot of wealth for this country. And that expertise was developed in Australia. That's not something where Boeing's brought it here. We developed it here, and Boeing obviously likes it a lot. And they really have, cornered a very important part of the plane manufacturing business. I don't think the people in Seattle are worried whether that's in Australia or Thailand or wherever it is. As long as it's clever and good and they can afford it, they'll keep buying it. And I think, I think the globalisation can also be an advantage, right? In other words, we should think about where we can win in that game. What I am confident about is we're not going to win a game where you make some product that people in China and India can make quite readily. That's maybe a quite standard product. How can we win that game? I don't understand how we can win that game. So I come from a sports background, as you know, Sharon. I always want to change a losing game. If I'm losing, I want to do something that's winning. And I think making standard products that people in China and India can make cheaper than you is the losing game. The winning game is to look for things that other people aren't so clever at making. And I'm sorry I can't give you more examples, but there are examples.
Yeah, I think there are plenty of examples where Australian manufacturers are doing very well in exporting to the world and in niche areas are really cornering the market. And it's normally in high-value things. It's not the commodity items that can be made by anyone, anywhere, but it is those high-value things. So I guess my last question is a follow-up really from Sharon's excellent question about the future of manufacturing. And I get the sense that here we feel like we could do anything and everything. We can make anything and everything and compete. And similarly in our research, we're free really to research whatever we want. So do you have any views on should we focus in certain areas, particularly in manufacturing and on certain products, or even should we be directing our research into certain areas to support those certain manufacturing industries?
What a really tough question.
This is to finish off with, and it's to draw in the any comments from the audience.
Yeah,
so if you want to throw it back to the audience.
That is an extremely tough question. I think picking winners can be dangerous. Some of us have lived through a few fashions. Ceramic engines in the 80s, remember that one? There are fashions, and you've got to be careful not to throw a lot of money at something that maybe is a little bit dubious in its value. So I think that picking winners is a dangerous game. However, having said that, there are some things in the world that are pretty clear, aren't they? I mean, it's very, very clear that alternative energy is likely to be a fruitful area in the world. You know, I don't think you need to be Nostradamus to see that one. And you know, there is. We picked steel before. It's not just because I like steel. I think even the most casual observation of the world would tell you, well, I think the steel industry is going to be pretty important for quite some time here. So we should try and be clever in particular areas that we think we'll be good at. So, for example, we criticise governments, but let's give them some credit. They've put some funding into the new hub, is the word, isn't it, for BlueScope here. And I think Brian Monahan did all the hard work to put that together. Good on him. And that's trying to get focus on developing new products in the architectural area and the areas that BlueScope's already got some advantages. So that to me looks like putting strength with strength and trying to make it succeed, you know, trying to get more success. So that looks wise. So I think I don't favour overall trying to pick winners, but I think there are a few areas that we can go through, and I don't think there'd be a huge number. I think we could 5 or 6 major areas. In Melbourne, I don't know the New South Wales scene as well as I know the Victorian scene. There's really, really strong strengths in the biomedical device area in Melbourne, and it makes sense that the government's going to encourage that. I think when you should get suspicious, Jeff, is when you sort of see people saying, we're going to put $10 billion into this thing that will change the world. You know,
Yeah, that was my next big idea.
That's when my antenna of scepticism starts rattling. I think there needs to be very good solid arguments why a government should heavily invest in 1 or 2 areas.
Yeah, and I think those examples make a lot of sense, so it's not really that hard to come up with that evidence. Look, I want to throw it back to the audience, and it's sort of getting to the time where we want to wrap things up, and we'll have time, and we've still got a few drinks left at the back there.
Is there one left for me, Jeff?
There might be. I think you've earned one. But let's just throw it back to the audience in case there's any more questions or comments. Maybe everyone's just keen for a drink. No comments, no questions? Oh, hang on. Here we go. There's a couple down the front here.
By training, I'm a nuclear physicist, therefore too far from steel making. I'm curious to know, you said a couple of times to improve the steel. What do you think can be improved in the process of manufacturing?
Oh, well, first of all, at the moment, we basically have a continuous front end in the blast furnace, and we then go into a series of batch operations, and then we cast, and most of the world is casting into fairly thick shapes, and then we roll it down, and there's a lot of steps there. So I think in an ideal steel plant, there would be more continuous. We would have iron coming out of the bottom of the blast furnace, being refined into steel, going into a casting operation, and would have a much smaller footprint. I think that's possible. That's one area that we could improve. Even just getting a better understanding how those processes work will allow us to make those processes more efficient. So I mentioned to you before, I won't go through the long, complicated arguments, but I think it's, for example, quite possible to make the same quantity of steel they're currently making at BlueScope in vessels half the size. I'm not saying it's, you know, I can click my finger and suddenly make it happen, but it's quite possible from what I can see of my knowledge of steel making. So I think there are improvements there in size and footprint of the equipment that could be achieved. On the quality side, I think there are issues there about, you know, coming up with smarter ways of refining the steel and allowing us to have more versatile inputs into the steel process. I don't think we've fully got that under control. For example, nobody's come up with a really good way of removing tramp elements from steel when you recycle it, and that's a big issue. People, when you throw bits of coinage or copper into steel, that's a criminal act. I can't tell you how hard it is to get copper out of steel. But any of you, I also can turn that on its head. If there's anybody in this room who thinks that they can come up with a way of getting copper out of steel, believe me, you'll make an enormous amount of money. There'll be statues of you erected outside this university. They'll name buildings after you. So if you can find that one. So I think there's a number of things in the refining side and trying to make the process more continuous.
Only if you donate most of that money back to the university. Did you have a question?
Yeah. Yeah, I was also thinking about steel. Your argument as to why we should, this country should continue in steel was really a correlation rather than a causation argument.
Yeah.
Places where you like to live. And I thought, what about Switzerland? What about Norway? Which we'd call pretty successful, but also, well, much smaller countries,
Yeah.
which are not in steel. And I was thinking, why not compare steel with the petrochemical industry? Basically, you wouldn't make, nowadays, polyethylene in this country. You don't do commodities unless you can do enough. And to my mind, our demand for steel is small. Why is it economic to do it here?
Yeah, well, let's take that one straight on. So, yeah, that's a good question to ask in terms of what sticks out about steel. The countries that you talked about, where they have small steel industries, and I think you picked two good ones. Norway actually may not make a lot of steel, but it makes some very high quality steel. But Switzerland, yeah, I'd definitely go along with that. I suppose it's a very particular situation. They're right next to all these other countries that can provide excellent raw materials to them. It's kind of integrated into France and German system. So, yeah, it's an example. I'm not sure how good an example, but it is an example. I think what you've got the follow up what you're saying is not to make something so standard. If you take the petroleum argument that you used, yeah, why want to get making the most basic type of polymer? That's right. Why do it? I don't think we should make the basic types of steel. So, for example, why are we making reinforcing bar at Sydney Steel Mill and down at Laverton? Now, I just can't see that's a winning game. So I'd agree. At that point, you and I are in the same place. So, all right, we either say we're not doing it, or we say, right, let's get to something higher value, something connected to a manufacturing follow-up that's going to lead to a high-quality product. So I think I would agree with I think you and I would agree, actually, don't make stock standard. But if you're going to make something, make it a bit special. And if you can't make that succeed, then I think your argument will just happen anyway. In other words, if we don't succeed in coming up with new products and desirable products from the steel industry, then what you argue will happen by just natural economic processes. So I think there's an element of agreement between you and I. I just think we don't have to go that way. I think we can be cleverer and do something that will bring value to our society. One thing I would say here is that I think you'd find that in the debate about countries that have a good steel industry and are wealthy, you'll find a very high population compared to the countries that manage not to fit that cliche.
Well, we'll just go to one last question from Chris Cook, our Dean.
It's always important to let the Dean ask a question in my...
Actually, me, I'm really intrigued and impressed with the idea of getting designers and engineers together. But I think one of the key things is where do the best... What do you have to do to get ideas to come up? Henry Ford once famously said that if you'd asked people what they wanted for the car, they would have said they wanted a faster horse. And so it's very hard to find out future ideas from current practices. And will designers and engineers together really do enough to cover it? Is there a missing ingredient to encourage the development of new ideas that are going to sell to the rapidly increasing Asian middle class, for example?
That's an excellent point. I think that you look at Australia has some very strong material science. I think we have some of for our population, a really very large material science schools around the country. And I think the thing that's a bit sad is that maybe those ideas in those material science schools are not as many as that should be are being commercialised or developed. So I suppose that if you follow that through, it's very important that the engineers and the designers are well aware of what's going on in those fields, and there's also things in physics as well. So I think naturally enough that means you have to have 3 or 4 people talking to each other. And as you know, because you're a dean, if you get 2 groups of academics working together, it's a minor miracle. 3, it's Nobel Peace Prize territory. So I think really it's basically about making sure that that engineers and designers mix and regularly see what is going on in physics and chemistry and material science. At our own university, we have some very, very strong people in photonics at Swinburne. Really a huge strength at our university. And yeah, it's a real effort to get that community of people mixing with these engineers. I think now, I know you're the Dean of Engineering, so I'm going to put a little bit of pressure on you now. I'm going to reverse it. One thing that I think that's a little bit concerning in Australia at the moment, we need a bit of controversy to end up, don't we?
Please.
Yeah, a bit of controversy is we have, I came back to Australia to discover that most engineering schools don't have physics as a prerequisite anymore to get into engineering degrees.
In high school.
Yes, at high school. That's a really dubious idea because, apart from physics being incredibly relevant to engineering, is because the language. So I studied 2 subjects of physics at university in my engineering degree. As a consequence of only studying 2 subjects, I actually can understand most things being said by people in the physics department, not everything, but a reasonable. When they get into dark matter, I get a little bit, I put my eyebrows up. And I studied quite a lot of fundamental chemistry as well, Hugh, because I know Hugh loves chemistry. You know, and so the chemistry, I studied enough chemistry and physics to be able to talk the language of what I understand what they're going on about, and that helps me appreciate their ideas. So I think we shouldn't lose that. We should try to make sure that engineering students and when I can understand the language of the physical scientists, because that's one of the best ways they can link up with them. But Chris, if you've got great ideas about how to get physics, chemistry, designers, and engineers working together, please share with all of us. It's not an easy place to be, trying to get that group of people understanding each other.
Well, I think it's also very exciting. We're blending together not only the scientists and engineers, but the social scientists, the creative artists, and people really from all sorts of different backgrounds, and some really wild things are happening in that space. So
yeah, I love it. I love that house. The house you've got down there. Yeah. What's it called? The
Solar Decathlon House.
Yeah, that's amazing. That's obviously a real example of that, where you've got many different groups of people trying to do something clever.
And they're all motivated around this common cause, which I think is the key. Look, I want to wrap it up there so we've got time for some more informal stuff, but really I think that was terrific, Jeff. It was a mixture of entertainment and wisdom and even some inspiring words in there, and you really made my job very easy. So I really want to thank you for being our first of the conversation in the manufacturing innovation area, and I really want to thank the audience for coming along and participating. It's not over yet. We've still got some time and some drinks up the back. This man here has certainly earned himself a drink. I think you'll agree, so let's put our hands together.
Thank you. Thank you very much.